Greetings, everybody. So today we'll start a new lesson, and our first topic in that lesson is going to be the parabola. Okay, uh, so we'll talk about that, and we'll also talk about this related concept of a quadratic function. All right, now I thought I would do it this way. Before I get into the details of how we're going to learn about parabolas in this class, I thought I'd tell you a little bit about the big picture, okay? So I am going to just use Wikipedia to show you a few things about parabolas and as far as their existence in the real world, okay? So if we looked into this, if we learned a little more about this, we would find that like satellite dishes, certain kind of reflectors and so on are cross-sectionally parabolas, okay? They're made from the basic shape of a parabola. And the reason for that is because a parabola has this thing called a focus, all right? And I tell you that just to tell you a little bit about the way these things work. So see, it's like these lines come in and they get bounced over to the focus, okay? Why would that be important? Well, with let's take a satellite dish. What we want to do is capture small satellite signals and turn them into a bigger signal. So you might imagine like all these signals come into this dish right here, which is a parabolic cross section, and they get reflected to the focus and they get concentrated at the focus. So you might say every little ray of satellite information is small on its own, but if they all get bounced over to that, then what you get is something much bigger, okay? Another example of that is this right here. I like this one a lot. It says this person is lighting the Olympic flame with a parabolic reflector. So you might imagine that sunlight is hitting every little spot on this parabolic dish. And any ray of sunlight is not hot enough to light a torch or to catch something on fire. But if it's the same principle as a satellite dish, where they all get reflected to the same spot, okay, then what you get is they all add together and like end up being hot enough to catch something on fire. So this parabolic reflector right here that concentrates the sunlight at the focus can light a flame. This radio antenna, same thing, okay? Catches all these basically radio signals from space and concentrates them at one point, making a bigger signal, or in this case, a more intense heat and light, okay? All right, so I just thought I'd tell you a little bit about that because if we get into the details of how we're going to learn about parabolas in our class, then it's not going to seem like it gets to anywhere. But trust me, like the existence of a parabola is a very important thing for us. Oh, one more. I forgot I had one more to show you. Anytime, like if I were to take my pen right here and like throw it in the air, the arc of motion that it would go through is a parabola, okay? So here's water launched out of a fountain, and you see those arcs, the motion of the water as it's launched out of this fountain and goes up and falls back down. That arc, that path, that shape is called a parabola. See, you can already see it here in my notes that's what I'm going to talk about. And you recognize that picture right here. It looks like the same thing. And that's what I'm going to be talking about. So any kind of ballistic trajectory is going to be parabolic. Okay. Something launched out of a cannon, water out of a jet, whatever it is. Okay. All right. Now let's talk about parabolas the way that we're going to learn about them in our class. Let's talk about what they look like. Now, I've already told you a little bit about that. It may have been easier to understand what a parabola looks like here and a little harder to understand when I talked about a satellite dish or something like that. But I'm here to tell you that these are the parabolas that we'll see. We'll see one that looks like this, and that one opens up, and we'll see one that looks like this, and this one opens down, okay? There are other kinds, but these are the kinds that we're going to look at. They could be wider than this. They could be more narrow than this. but you see the essential shape. An important detail about a parabola is that it has a vertex. All right, that's this point at the very bottom if the parabola opens up, or the very top if it opens down. Okay, so finding the vertex will be a big deal for us. That's one thing that we're going to try to identify about any parabola that we're going to see. It's a key point. Most of the other points are nondescript, I guess you could say, at first glance, but the vertex is one that will be important. All right. One other thing, as far as I'm talking about what parabolas look like, well, so there are lots of details that you could analyze as far as what a parabola looks like, but I'm going to stick to a certain few things. Okay, so we got the basic shape, you got the vertex, the point at the bottom or the top, and then another thing about a parabola is that it's symmetric. And what I mean about symmetry is that it's a mirror image of itself across the middle. Or if you were to cut it down the middle, right through the vertex, the right hand side and the left hand side would appear identical. Okay, mirror images of each other. So all parabolas are symmetric about the vertical line that goes through the vertex. So remember, we talked about it up there. The vertex is this point at the very top or very bottom, depending on whether it opens up or down. So if I could imagine a line going through that, that would cut it in half and make mirror image on either side. That's what we mean when we say parabolas are symmetric. Okay. All right. Now, as far as terminology goes, it's just a matter of fact that parabolas are symmetric, but we call that line, okay, that goes through the vertex, the axis of symmetry. All right. And I'm certain that you will come across that term as you go through the assignments. Okay. All right. So that's what parabolas look like. I didn't do any math. I didn't write a single number down so far. I just wanted you to get a feel for what a parabola looks like before we go into the details and the math, which we'll do now. Okay. So let's go to this next part. What is the equation of a parabola? So as far as a parabola is something that we might see on a graph, okay, or make measurements out of, then it has an equation. Now, there are two forms of the equation, and you're going to see them both. It would be nice if there was just one form in standard practice, and that's the only one you had to learn. But that's not the way it is. There are two. So let's go through each one. So equation 1, or type 1 that you might see, says y equals a times x minus h squared plus k. Now, y and x are our variables. In all the equations we deal with, you plug in the x, you do a little math, and you get the y. That's what x and y are. This a, h, and k, those are going to be known numbers. So they'll be identified in whatever problem that you're working on, or at least for us. So the x and y, you plug the x in, you get the y out. The a, the h, and the k are going to be known numbers. Now the details about this equation, or let's think of it like this. When you see an equation like this, here's 3 things I'd like you to know right away. Okay? If a, that number right there, is greater than 0 or positive, however you want to say it, the parabola will open up. So what am I saying? If that number was positive, I know that the shape of the graph is going to be like that somehow. Maybe it's wider than this or more narrow, but it's going to look like that. It's going to be a parabola that opens up. If a is less than 0 or negative, however you want to say it, then the parabola will open down like that. So over on the other side of the page over here, we talked about how a parabola can open up or down. When I have an equation that looks like this, if that number is positive or negative, it will tell me. And last, what was the other detail that I said would be important? The vertex. Okay, this point, this lowest point if it opens up, or this highest point if it opens down. It turns out that you can determine that from the equation. The vertex is h and k. And what I mean is if this says x minus h, the x coordinate of the vertex is that number h plus k, and the y coordinate of the vertex is that number k. So you get an equation that looks like this. The numbers that constitute the vertex are right there in the equation. Now, I think that last part needs an example. So we'll do an example of this last part of finding the vertex. Okay, so let me give you an example of an equation of this form, and then we'll find the vertex and you'll see what I mean. So let's see, let's do this one. So this one I took from my math lab. It says in the following exercise, find the coordinates of the vertex, so on. So does that resemble this? Y equals ax minus h squared plus k. Yeah, it's got all those parts to it. 4, that's the a. So let's write down everything. All right, so a would be 4. Like if you wanted to compare to that, h is going to be 5. And what's k? I noticed there's a difference about the form I wrote down and the form this is over here. So this says plus k, like so plus some number k, whatever it is, but that says minus. So what's the deal with that? Can I say that k is minus 3 like that, or should I say it's 3 and so on? Well, the way that it works is that there are many ways you can think about this, and I guess I'll have to leave it up to you ultimately how you want to think about it. But I might look at this as 4 times x minus 5, and if you wanted to read like this, I'll say plus the number negative 3, because if I said plus the number negative 3, that's the same as minus 3. But when I do it like that, it looks like this. Okay, and then k would be minus 3. All right, so there's the comparison. All right, so let's do this. The vertex then, what did we say it would be? It would be h and k. The x coordinate of the vertex is h, the y coordinate's k. Now, I tried to make a comparison between the formula I gave you and the way that it appears here, right? And I said I want to see a plus, so I wrote a plus. I got to keep my numbers the same, so I said plus minus 3. And so my vertex is going to be like this with a, h, and k. We'll say 5 and negative 3. There's your vertex. That's what we would submit for an answer. Okay. Other details. It also opens up, I notice. This question doesn't ask me about that, but if it should come up in the future, then I know that much about it. Now, I want to stress this. The vertex is a point. Okay. When I say the vertex is parentheses 5, comma, negative 3, close parentheses, I'm telling you that it's a point on a graph. I could draw a graph on graph paper of this parabola if I want to, and one of the points on it is this one, 5 and negative 3. Okay, so let's explore what that would mean. Okay, don't forget the vertex is a point. We can graph it. That's the significance of those numbers. So the way that this parabola would look if I was going to begin to graph it, I plot the vertex first. So I go right 5 and I go down 3, and it would be right there. And then there would be lots of other points on it, but it would have this general shape. It would open up like that from the vertex being the lowest point on the graph if it should open up. Now, I'm not saying it looks exactly like that. I'm not saying that this is how wide it is, or it's kind of sloppy looking, my hand's not steady. All I'm trying to tell you is that that's what we mean by the vertex. It's a point. We can plot it. It's got an x coordinate and it's got a y coordinate, and that's how we understand it. All right, now let's do this next problem just for the sake of a little variety. And so for this one, I would say a is negative 2, and then I want to identify h and k. All right, so let's compare with the way that I gave this to you. I said the form of the equation is ax minus h squared plus k. So I got a's pretty obviously negative 2. All right. And then it says x minus h. But over here, I don't see a minus. I see x plus 8. Okay. And so it doesn't match. And mathematics is very precise. It's not really open to your interpretation or how you feel about things. So I need to see that this matches. Like if I'm going to make a direct comparison and read these numbers off of it and tell you what the vertex is. So how could I do that? Could I make this be like x minus, like it's over here? And what should h be? Like I have to have the same number. I can't make the numbers different. I'm just trying to make the format different. So I could do like this. X minus negative 8. Isn't that the same as x plus 8? It is. When you subtract a negative, same thing as adding. But does it now read like that? X minus h? Yeah, it does. It says x minus, and h must be negative 8. And then k, so it says plus k. Well, I've already got a plus there, so I'm in good shape. So k is 1. All right. So, okay, I think I got it then. The vertex is h and k. H is negative 8. And k is 1. All right. And that's what I would put in there to submit for my answer. That's a point. Once again, I could get graph paper out. I could plot it. I could tell you and show you where the vertex is on a graph if I wanted to. At some point, we will graph parabolas. And plotting the vertex will be part of it. For now, I just want you to understand that that's a point. All right. They might call it an ordered pair too, but you could call it a point, a spot on the graph, whatever you want to say. Now, one more thing about this one. Notice that when I wrote down the form of the equation for you, I wrote y, but I see in these it says f of x. Does that matter, and does that make a difference? It doesn't make any difference practically for us as far as answering this question. They're interchangeable. The reason why we write f of x sometimes is because it allows a shorthand way to summarize what we do. Like, so if I wrote f of 4, that would signify what do you get when you plug in 4 to this function. Okay? So it's like giving me instructions. This function notation is an easy way to communicate plugging a number in and you making a statement of what you get back out. What would I get? 4 minus 5 is negative 1. Squared is 1. Times 4 is 4. Minus 3 is 1. Okay. So, you know, it's the same thing. If I give function notation, it's a little bit of a shorthand, but still it's a way to communicate that the x is one thing and the y is another. In that formula, if I plug x in, I get 1. If I plug 4 in for x, I get 1 back out for y. If I just write y, then I guess I could tell you that if I plugged 1 in for, or 4 in for x, I get 1 for y. But function notation is a shorthand way to do it. You could still just write it like that if you wanted to with the y. Okay. So the next form of the equation is going to be like this. And it takes a little more analysis, a deeper analysis, a little more math, and so on. It's a little more complicated. So I'll talk about that in my next video. Okay. But one last detail about this one. I notice I titled it Parabolas and Quadratic Functions. So a parabola is a shape. It looks like this. A quadratic function is a function or a formula. Okay. And it looks like this, or it looks like this. I know we haven't talked about that one yet, but it's another equation. It's another formula. It's another function. So both of these equations, one I've talked about so far and giving you some examples, the other I haven't. Those are quadratic functions. The graphs of a quadratic function will be a parabola, okay? But just to differentiate them, one of these things is a shape, the other is an equation or a formula, and they're related as you see here.